Today we are going to discuss about the catalysis. We can see that what is the definition for the catalyst. Catalyst, it is defined as the substance which alter the rate of the chemical reaction without undergoing any change in the amount of chemical composition at the end of the reaction. That means the substance which increase or decrease the rate of the chemical reaction without undergoing any change in the amount. So we call it as a catalyst. And here we have two types of catalyst. So one, it is a positive catalyst and another one is the negative catalyst. Positive catalyst is nothing but what? Which enhance the rate of the reaction. We call it as a positive catalyst. That means which increase the rate of the reaction. Negative catalyst is nothing but what? Which retard. That means it decrease the rate of the chemical reaction. We call it as the negative catalyst. Otherwise, we can also call it as inhibitors. So, what is catalysis? Catalysis is nothing but which altering the rate of the chemical reaction with the help of the catalyst is known as catalysis. And we can have a question here: how does a catalyst increase the rate of the reaction? The catalyst which increase the rate of the reaction by lowering the energy barrier between the reactant and product. Otherwise, we can also say like this: the catalyst provide another path for the reaction that has lower energy of the activation. You can see the diagram here. The reactant is converted into product. We have x-axis progress of reaction and the y-axis energy. So without catalyst, you can see that the reactant goes to the activated complex and it is returned to the product. So the energy barrier, if you see that using the catalyst, it is immediately the reactant is converted into product. That means the energy gap is very low. So we have the types of catalysis. Then we have two types of catalysis. One is a homogeneous catalysis. Another one it is heterogeneous catalysis. What is the homogeneous catalysis? Is nothing but the homogeneous catalysis are the reaction in which the catalyst as well as the reacting substance are present in the same phase. That means reactant, product and catalyst. If it is in the same phase, then we call it as a homogeneous catalysis. For example, if it is the reactant is liquid, and the product also liquid and the catalyst also liquid phase. If the reactant is gaseous phase, the product as well as the catalyst also in the gaseous phase. So this is homogeneous catalysis. And what is that heterogeneous catalysis? It is nothing but we have the different phases. More than one phase, if it is there in the reaction, then we will call it as heterogeneous catalysis. That means reactant, product and the catalyst are having more than one phases. The reactant is in the liquid phase, catalyst is in the solid state phase and product also it is in the liquid phase. So it is called what? It is a heterogeneous catalysis. And you can see the example: sulfur dioxide and oxygen in the presence of catalyst platinum, it gives that what? Sulfur trioxide. So it is about heterogeneous catalysis. And you can see that sulfur dioxide plus oxygen in presence of nitrous oxide, it gives sulfur trioxide. All the reactant, product and catalyst are gaseous phase, single phase. Example for the homogeneous catalysis. And then we see that what is the difference between this homogeneous and the heterogeneous catalysis. Here the first point itself it is given. The reactant, product and catalyst are present in only one phase. And in heterogeneous, it is there the different phases. And in the homogeneous, catalyst cannot be regenerated. But in the case of heterogeneous, the catalyst can be regenerated and also it can be activated. And here, the thermal stability of the catalyst is low in the case of homogeneous. And thermal stability of the catalyst is high in the case of heterogeneous catalysis. The reactions are carried out at lower temperature and lower pressure, but in the case of heterogeneous catalysis, the reactions are carried out at high temperature and high pressure. And the temperature increase the rate of the reaction. In the case of heterogeneous catalysis, temperature increase the rate of the reaction. Both it is, we have, when the temperature increases, the rate of the reaction also increases. And the selectivity of the catalyst does not depend on the physical nature in the case of homogeneous catalysis, but in the case of heterogeneous catalysis, selectivity of the catalyst depends on the physical nature. And then we come to the characteristics of the catalysis. That we have around 5 characteristics of the catalysis. That number 1, the catalyst remain unchanged in amount and chemical composition at the end of the reaction. That means it remain unchanged. It means what? It will take, it will initiate, it will foster the reaction and it will not take part in the chemical reaction. We will get the as it is in the end product. That is that what catalyst remain unchanged in amount and chemical composition at the end of the reaction. And the second point is only a small amount of the catalyst is required. It's not huge amount is not required to initiate, that means to foster the reactions. The catalyst aluminum chloride functions effectively when it is quantities more than 30% of the quantity of benzene. It's very small amount, it is enough for the reactions to take place. And third point, the catalyst does not alter the position of equilibrium in a reversible reaction. That in the combination of sulfur dioxide and oxygen, there is platinized aspartate as a catalyst, increase the rate of the reaction, but it does not increase the yield of sulfur dioxide. And then we have the fourth point, the catalyst is specific on its reaction. Because when a particular catalyst works for one reaction, it will not work for another reaction. Different catalysts can bring about completely different reactions for the same substances. The fifth point, generally catalyst cannot initiate a reaction because already the reaction will be started and just only it will foster the reaction. That's what it is given. The catalyst cannot initiate a reaction. In most cases, a catalyst speed up the reaction already in progress and does not initiate. And the sixth point is the catalyst is more effective when it is finely divided. For example, if you take a heterogeneous catalysis, a finely divided solid catalyst is more effective than it is used in bulk. That we are going to discuss soon. And the last point is optimum temperature. What is optimum temperature? That is what the particular temperature, the catalyst it is what active. The catalyst it is most active at particular temperature. We call it as a optimum temperature. The catalyst is poisoned by the certain substances. The presence of small amount of impurities, it will decrease the rate of the catalyzed reaction. These impurities are called catalytic poisons or anti-catalyst. And also, one more characteristics of the catalysis is it is enhanced by the promoters. The addition of the small amount of substance which increase the activity of the catalyst, such substances are called promoters. We have what is the catalytic reaction, how the catalyst is taking part. That it is we have in the 4 steps that we can explain. The action of heterogeneous catalysis, it is given. Step 1, absorption of the reactant molecules. The surface of the solid catalyst possesses a small isolated active center which absorb gaseous reactant either by physisorption or chemisorption. Here we have to see that there is a 2 type, that is absorption and absorption. Then here the absorption is taking place. You can see the steps 1 in the diagram. The nickel it is a catalyst, the hydrogen molecules are absorbed. In the second steps, the formation of activated complex. The absorbed molecule adjacent to one another join to form an intermediate complex. Here, that activated intermediate complex is unstable, which is shown in the figure. And the third step, it is a decomposition of the activated complex. The activated complex breaks to form a product. That means the separated particles of the products are bound to the catalyst surface by partial chemical bond. Here in the third step, which is the given ethylene molecule, it is what attached with the catalyst. The fourth one, desorption of the product. The product are desorbed, otherwise it is released from the surface. They are stable now. So this is the what catalytic reactions. Here we have the second important points to be discussed now in the catalytic reactions. I said just before, the finely divided state catalyst is more efficient. You can see the diagram. You can have the number of nickel, that is nickel catalyst element. We have around 9 elements. The free valencies are there, that you can calculate 12 free valencies are there in the bulk. At the same time, if you subdivide this nickel catalyst, that is 9 into 4, around 36 valencies are there. That means what? When this subdivided particles are used, and the reactions will be very fast. That means the catalyst is more efficient or active. And also that enhance the activity of the rough surface catalyst. If the catalyst surface is rough, it is nothing but if you have that number of peaks, number of corner, number of crack, if it is more, the number of active centers are there, the active center increase the rate of the reactions. That means the absorption will be fast and reaction also it will be fast. And then action of the promoters. The promoter is nothing but what? The substance increase the activity of the catalyst. The catalyst is nothing but what? Which increase the rate of the reaction. To increase the rate of the reaction that we are using the catalyst, to fast up the catalyst that we are using one substance that we call it as a promoters. We can see the diagram here that we can have a nickel catalyst. It is bound together and the strong covalent bond, the nitrogen molecule which is attached to the nickel, and we can see the distance between these two atoms, it is very less. But when we use that promoter, it is a molybdenum, it is a promoter, and it will increase that the distance, and it will weaken the covalent bond, it will cleavage very easily. So that is the function of the promoter here. Then the action of the catalytic poisons. What is that the catalytic poison? Just like the promoter is nothing but what? Just I said, which will increase the rate of the reaction of the catalyst. At the same time, the poison, catalytic poison is nothing but what? The substance which destroy the activity of the catalyst. To accelerate a reaction, this process we call it as catalytic poisoning. So here we can see that what? The platinum is a catalyst, and here that the carbon monoxide. When the carbon monoxide it is bound with the platinum, we have a bond. So there is no further reaction to be takes place when we use this one. It is what it will be poisoning that what it destroying the activity of the catalyst. Okay, then finally we have one more catalyst. We call it as a autocatalyst. What is that autocatalyst? That is the product when one of the product of the reaction itself act as a catalyst for that reaction. The catalyst is called autocatalyst. The process, the phenomena is called autocatalysis. That means we are not using any catalyst separately. When the reaction starts, the product it is started to form. So one of the product itself it is acting as a catalyst. Here you can see ethyl acetate. It is when it is hydrolysis, the acetic acid and ethyl alcohol is formed. The acetic acid here it is acting as a autocatalyst. Okay, thank you for watching.